Hello everyone and welcome to Apticom Careers online classes. Today we'll take up calendars part 2. In part 1 we had discussed a very important concept, that is odd days. Today we'll take up another concept in calendars which we call as leap years. Okay. Hope you understand what is a leap year. A year having 366 days or having 29 days in February month is called a leap year, right? So a leap year will have 0 to odd days. I had already discussed in part 1, right? So here we will focus on how to check whether a given year is a leap year or not. So write down to check if a year is leap year or not. In order to find this, any given year we should check whether that particular year is a century year or a non-century year. Century year means a year ending with 2 zeros, right? Like 2100, like 1600 and so on. A non-century year is a year not ending with 2 zeros, like 1920, 2110, 1760 and so on. So once we understand that the given year is a century year or a non-century year, we can find out whether it is a leap year or not. If the year is a non-century year, simply check if it is divisible by 4. If the year is divisible by 4, that means it is called a leap year. Like here, this is divisible by 4, so it is a leap year. This is not divisible by 4, so this is not a leap year, right? This is also divisible by 4, so here again it's a leap year. In this case, if the year is a century year, then you should divide it by 400. Like this year is divisible by 400? No. So this is not a leap year. This one is divisible by 400? No. So this is again not a leap year. This one is divisible by 400? Yes. So we say this is a leap year. Many students have problem in finding as to when a year is divisible by 4 or not, right? So this is specifically dealt in topics like numbers. So what is the divisibility rule of 2? I had discussed divisibility rule of 4, 8, 16 and so on, right? So let us take, suppose divisibility rule of 2. Say a number like 2168. The last digit is divisible by 2, that means the number is divisible by 2. Divisibility rule of 4, 2174. The last 2 digits should be divisible. Here 74 is not divisible by 4, that means 2174 is not divisible by 4. Like 2168. 68 is divisible by 4, that means the whole 2168 is divisible by 4. Right? What is the divisibility rule of 8? 21768. Whether this number is divisible by 8, then we'll check the last 3 digit is divisible or not. Here the last 3 digit is divisible by 8, that means the entire number is divisible by 8. It's very interesting to note that 2 means 2 power of 1, that means we are checking the last digit. 4 means 2 power of 2, that means we are checking the last 2 digit. 8 means 2 power of 3, that means we are checking the last 3 digit. Hello everyone. Let us continue with our topic, calendars. In the previous 2 sessions, we have discussed few important things. If you remember, we had discussed odd days concept, and in the next session we had discussed leap years, right? today we will see the various applications. Okay. One very common type of question comes when a particular day is given for a particular date and you are supposed to find out the day for another particular date, right? Like for example, say if 15th February 2002 was Monday, okay, then they may ask you to find 14th September of the same year is what? Let's take one more question. If 15th February 2002 is Monday, then they may ask you what is 17th March of 2003 and questions of this kind, right? So let us take the first one. So if I solve the first one, you see, let's take an example. Suppose first of any month is Monday, then what is 8th of that month? Will again be Monday, right? Because the difference of 7. So what is 15th of that month? Will again be Monday. Again you see the difference is 7. So we understand that if the difference of the two dates is a multiple of 7, the day will repeat. And suppose if somebody is asking you what is 9th of that month, then of course it will be Tuesday, right? So if the difference is 7, the day repeats. If the difference is 8, it will be one day ahead of that day. Okay, so let us take it from here. So 15th February 2002, from here till 14th September 2002, how many days are there? So in February, this is not a leap year, so we'll have 28 days. So we have 13 days left in February. Then comes March, February, and then is March, April, May, June, July, August. July, August are the same. And September, there are 14 days in the month of September, right? So all we'll do is now find the number of odd days in this. I had already discussed the shortcut to find the odd days in my previous lecture. So 13, if I divide it by 7, I'll get 6 as the remainder. Here 3, 2, 3, 2, 3, 2, here again 3, and this is 0. Now I'll remove the combinations of 7, they're like 4 plus 3 7, and then 6 3 is 18, 18 plus 6 is 24. 24 I'll further divide by 7, I'll get 3. So since I'm getting 3 odd days, if this was Monday, 3 odd days ahead will be not Monday, Tuesday, Wednesday, Thursday, right? So if it is 3, it will be 3 days ahead. So Tuesday, Wednesday and Thursday. So this particular day will be Thursday. Is this clear? Now, in the second question, question number 2, you see from 2002 it is going to 2003, right? Again, I can do this way, but here the year is changing. If the year changes, we have a better approach of solving such questions, right? What you can do, you can understand that suppose from 2002 February you are going to March of 2003, right? Say from 15th February you want to check. So if 15th February 2002 is Monday, then what will be 15th what will be 15th February of 2003? It will be just one day ahead, right? It will be Tuesday, because 2002 is not a leap year. So when you're crossing from 2002 to 2003, you're not crossing the February of 2003. Therefore, it will advance only by one day. But suppose if it was like this, 15th February of 2003 is Monday, and they're asking you, suppose it is 15th March of 2003, and they're asking you 15th March of 2000. So it's not 2003. Let's say this is 2004. So 2003. Let's keep it 2002. You want to go to 15th March of 2004. So this is Monday. What will be this? Of course, when you are crossing the February of 2004 is a leap year. So instead of Tuesday, and instead of advancing by one day, it will advance by 2 days. So instead of Tuesday, it will be Wednesday. Hope this is clear. Okay. So you can see that 15th February 2002 is Monday. Then I can write in this that 15th February of 2003 will be Tuesday. And from here I want to go to 17th March of 2003. So in February, how many days are left? This is not a leap year. 2003 is not a leap year. So I have just 13 days here, February, and then this March will have 17 days. So how many odd days in this? 6. How many odd days in this? 3. So I have 9 odd days. Again, I divide it by 7, I get 2. So it will advance by 2. So if it is Tuesday, it will be 2 days ahead. So it will be Wednesday, and the next one will be Thursday. If it was 1, if it is 0, it will repeat. If it is 1, it will advance by 1 day. If it is 2, it will advance by 2 days. So instead of Tuesday, it will be Wednesday and then Thursday. So 17th February 2003 will be a Thursday. So my answer will be, for this one will be Thursday, and for this my answer will also be Thursday. Alright. Let us take one more example. Say 17th April of 2015 is Wednesday. They're asking you 23rd November of 2017, right? So from 15 I can go till 2017. So I can find out what will be my 17th April of 2016, and from there I can find out 17th April of 2017, right? So when I'm crossing the April of 2016, I'm actually crossing a leap year. So instead of Wednesday, it will advance by 2 days. Wednesday, Thursday, and then this one will be Friday, right? And when I'm crossing 2017, February of 2017, it is not a leap year. So I'll just advance by 1 day here. Here I'm advancing by 2 days. So this one will become Friday, Saturday, and then it will become Sunday, right? Now from 17th April 2017, all I can do go till 23rd April 2017. So how many days in April left? I think 13 days. 3rd April, then May, June, July, August, September, October, and then in November I have 23 days. So again, finding the odd days in this, I have 6, 3, 2, 3, 2, 2, 3, and then this one will become 2 again. Now remove the combinations of 7. I think this 4 plus 3 is 7, and again 4 plus 3 is 7. I get 9. 9 again I'll divide by 7. I'll get the remainder as 2. Right? Now since this was Sunday, it will advance by 2 days. The Sunday, it will be Monday and then Tuesday. So my answer for this particular question will be Tuesday. Alright? Okay, let us continue. So far you have seen that given a particular date and a day, they are asking the day for some other date, right? So I have taken 1, 2, 3 examples. Okay, so let us continue. We'll take up, let me take a new page. All right, now another type of question. This is a very interesting one. So hope you guys know that a particular calendar is actually reprinted. It actually repeats itself. Say the calendar of 1996. If I ask when will this calendar repeat itself, or the calendar of 2000, when will this calendar repeat itself, right? Or calendar of 2010, when will this calendar repeat itself, right? So as we understand by the odd days concept that every 7 days a day repeats. In the like manner, in case of year also, whenever we complete 7 days, the calendar repeats. Also, we should remember that a leap year has 2 odd days and a normal year has 1 odd day. I've already discussed this one in the previous class, right? All right. So let us solve this particular question. So all we have to do is for 1996, then 97, 98, 99, 2000, 2001, like this I may write, and then write down the number of odd days. In 96, it's a leap year, so it will have 2 odd days, 1, here 1 odd days, 1, and then again 2 odd days, right? So I should continue writing till I don't get a 7. Like see here, 2, 3, 4, 5, 6, 7. Here I'm completing 7, right? 3 to 5 plus 2 is 7. The moment I complete 7, I'll just draw a line. So this line indicates that 1996 calendar will actually repeat 2001. So here my answer will be 2001, right? Let us see the second one. Now they are asking calendar of 2000. So calendar of 2000, then again 2001, 2002, 2003, 2004, 2005, 2006, and so on, right? So now what I'll do, I'll write down the number of odd days here. 2, 1, 1, 1, 2, 1. So here you see 2, 3, 4, 5, 6, 7. Again I'll make a line. It means that 2000 calendar will actually repeat in 2005. So my answer for this question becomes 2005, right? Now the third question, you see 2010 calendar. When will it repeat? So 2011, 12, 13, I should write 14, 15, 16. So how long should I write? You continue writing till you don't get a 7. Like here it will be 1, 1, 2, 1, 1, 1, 2. So 2, 3, 4, 5, 6, 7. So I'll make a line here. Again 2000 calendar will repeat 2016 calendar, right? So if somebody is asking you 2020 calendar, when will this calendar repeat? So again 21, 22, 23, 24, 25, 26, 27 and so on. So here I'll write 2, 1, 1, 1, 2, 1 and so on. So 2, 3, 4, 5, 6, 7 and again make a line. So it means this one is going to repeat. Now suppose it doesn't make 7, it makes 8. Then I should not say this one will repeat like 2, 3, 4, 5, 6, 7. No, here it's not making. So let me say 1996 calendar. Did I check? Okay. So now I have a very interesting question for you guys. Can you tell me when does 2011 calendar will repeat? Take a moment and think. You can pause the video and then try it on your own. I'm doing it for you. So 2011 calendar, 12, 13, 14, 15, 16 calendar, 2017, then 18 and so on, right? So it will have 1, here 2, here 1, here 1, 1, 2, 1 and so on, right? Here again 1. So you see 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Now here I am getting 8. So I cannot say I cannot make a line here. I cannot say 2011 calendar will repeat 2017. I'll continue. So 18, 19, 20, 21, 22, 23. So sir, how long should I continue? You will continue as long as you don't get 7, 14, 21 or the multiples of 7, right? So here you're getting 8 till here. You're not getting 7. You need to continue. So 1, 1 and this will again be 1. 2020 will be 2. This is again 1. This 22 will be 1. Again 1. So this till from here to here it was 8, 9, 10, 11, 12, 13 and then this is 14. Then you need to make a line over here. So it means that 2011 calendar will repeat. Sorry. It means that 2011 calendar will repeat 2022. So my answer for this question will be 2022. Okay. Now there's another type of question when they will ask you the day for a particular date. Say 26 January 1950 was what day? Monday, Tuesday, Wednesday or something. They may ask you something like 15th August 1947 was what day? Monday, Tuesday and so on. Or you can also find out your own birthday. So like my birthday is 22nd November 1988. I can find out my birthday, right? Not date. Date I already know. Anyway, okay. So this is one kind of question. See, in various books you will find some code given to find out the particular day for a given date. But I don't rely on that code because reasoning, mathematics is not about remembering stuff. It is about using your logic to actually solve questions, right? So we'll not go by that particular code because people generally forget that. What we'll do, we'll learn something very important. In order to solve such questions, there are certain things you should understand, right? So you can please note down these things. See, first of all, we'll understand that every 100 years has how many odd days? 200 years, 300 years and 400 years. We'll find out and remember 100, 200, 300 and 400 years has how many odd days. As of now, I actually remember that this is 5, this is 3, this is 1 and this is 0. I'll also explain it to you why is this happening, right? See, I'll talk about this 100 years. This is most crucial. So can somebody tell me 100 years will how many odd days? if you remember, I had discussed, say, 47 years as how many odd days. I had told that you have to check, number one, how many leap years are there in this and how many normal years are there in this. So in this case, if you remember how to find the number of leap years, I'll divide 47 by 4, I'll get 1 and 1, that is 11 leap years are there, and 36 normal years. Every leap year has 2 odd days, so there are 22 odd days. 36 days in normal year, 36 normal years means 36 odd days. So when I add it, I get, again, I can divide it by 7, I get 1, and I get it divided by 7, I get 1. So I get total 2 odd days, right? So in the like manner, if you do for 100 years, then you will get 25 leap years, right? Sorry. You get leap year, not a leap year. So you get 100 by 4, that is 25 leap years, and you get 75 normal years. So 25 means 25 leap years means 50 odd days. 75 normal years means 75 odd days. 50 odd days means 1 odd day, and 75 odd days means 5 odd day. So 1 plus 5 comes out to be 6. So your answer will be like 6 odd days. It appears. In fact, this is not true. So 100 years will not have 6 odd days. Instead, it will have 5 odd days. I'll explain you why. See, this calendar which we are referring is actually Gregorian calendar, right? So whenever we say that a particular day is Monday, so there has been some reference, like 1st of January, this, suppose they had assumed that this will be Monday. Keeping this as a reference, they started finding out the days for the different dates, right? And so on. So if you see 100 years, like 1 AD, 2 AD, 2 years, 3 years, 4 years, like this 100 year, in this, every 4th year will be a leap year. Then 8, then 12, 16, and so on. So the last leap year will be 96. The 100th year is not a leap year, because we remember that 100 is a, say, 100 AD. 100 is a century year, and a century year is a leap year only when it is divisible by 400. So here 100 is not divisible by 400, so 100 is not a leap year. So in 100 years, I have leap years only from 4 to 96. So we can find out how many terms are there. The number of terms in this is nothing but the number of leap years, because a leap year happens every 4th year. So here 1 leap year, another leap year, another leap year, and so on. So if you remember, this is a given data which is in arithmetic progression. Here the common difference is of 4. So how many terms are there? We know the formula, TNF is equals to first term plus number of terms minus 1 into the common difference. So the last term is 96, first term is 4, number of terms we need to find out, and the common difference is 4. If you solve this, you will get n as 24, not 25, unlike this calculation. So this calculation is not true if it is a multiple of 100 years. If it is for 100 years, if this calculation will not come to be true. So 100 years will have 24 leap years and then 76 normal years. So every leap year 2 odd days, so 24 leap years means 48 odd days, 76 normal year means 76 odd days. And when I find the odd days for this, I get 6 here, I get 6 here, this becomes 12. Again, when I divide by 7, I get 5. So we understand that 100 years will have 5 odd days. See, I don't want that you people remember so many things, right? It is just an explanation why for 100 years I wrote 5 odd days. At the end, to solve questions of this kind, all you have to remember is this. You mug it up. 5310. 100 years will have 5 odd days. Now, 310 you did not remember. Just remember that 100 years will have 5 odd days. Because this one you can find. Because 100 into 2 is 200. And 5 into 2 is again 10. 10 when you divide it by 7, you get again 3. So this is 3. Similarly, 100 into 3 is 300. And 5 into 3 will be 15. 15 is again divided by 7 to get 1. So I get 1 here. So I need not remember 3, 1 and 0. Now this part I should remember. Because if you multiply it by 4, you get 400. But here if you multiply it by 4, you get 20. So 20 on divided by 7, you don't get 0. So this one you should remember that every 400 year will have 0 odd days. So you can make a note. Note is every 100 years will have 5 odd days. Not every, sorry. I should rather say 100 years. This is point number 1. Another you should remember that every 400 years will have 0 odd days. So can you tell me how many odd days will be there in 800? 0. 1200? 0 odd days. 1600? 0 odd days. So all these are multiples of 400. Okay? All right. So, hope you understand that every 400 years will have 0 odd days and every 100 years will have 5 odd days. This is very important. Now, having said this, let us find the day for 26 January 1950, right? This was the question. I want to find the day for this. So what you can do, that 1950, so first 1600 years and then comes 300 years, it will become 1900 years and then 49 years. And in the 50th year, you have 26 days, right? So what am I doing? We are going to find out the number of odd days starting from the first day, that is first, and first. This starting from this, right? So in 1600 years, how many odd days? 0. In 300 years, I think you can see, in 300 years, I had already written, it will have 1 odd day, right? So you can write 1. Now for 49 years, I can do it in rough. So again, leap year, normal year. How many leap years will be there in this? So I think you can understand 12 leap years and then 37 normal years. 12 means 24 odd days. 37 means 37 odd days. 24 means 3 odd days. 37 means 2 odd days. And total it will become 5 odd days. So I'll write 5 here. Now in 26 days, how many odd days they will be there? It will be 5, right? 7 by 7 3 21 and remainder is 5. So totally you will have 11 odd days. Again you divide it by 7, right? And how much is it coming? 4, right? So if the odd days which you get, suppose you get 1, then the day will be Monday. 2, it will be Tuesday. 3, it will be Wednesday, and so on. 4 will be Thursday. 5 will be Friday. 6 will be a Saturday, and 7 or 0 will be a Sunday, right? So here it is 4. That means 26th January was a Thursday. Alright, let us do one more question to understand. So I have already given this example. 15th August. August is 8, 1947, suppose, was what day? So again we can do it like this. We'll find the number of odd days starting from 1600. So why are we doing this 1600? Because to come to 1947, the first 1600 years will have 0 odd days. And then comes 300 years, 1900 years, then I'll have 46 years, and my 47th year will start from January, will go from January, February till 15th of August, right? So I'll have, in 1600 years I'll have 0 odd days, 301. Now in 46 years I can find out in rough. In 46 years, let me do it here itself. In 46 years again, leap year, normal year. 46 years will have 11 4s are 44, and then 35. 11 means 22, 35 means 0, 22 plus 0 is 22. Again I divide it by 7, I get 1, right? So I'll have 1 here. Now from January till 15th, I'll write January, February 1947. This is the 1947th year, is not a leap year. So this February will have 28 days. February, March, April, May, June, July, August. This August will be 15 days, right? 15. So this will be 0 plus 1 plus 1. Now here 3, 0, 3, 2, and again 3, 30 will be 2, then 31, 3, and then 15 days will be 1. I'll remove the combinations of 7, right? So 2 plus 2, 4, 4 plus 3 is 7, 3, 3 is 6, 6 plus 1 is 7. So I get 3 plus 1, 4, and plus 1, 5. I get 5 odd days. 5 odd days means it should be a Friday. So 15th August 1947 was a Friday. Okay. One last question. I think on the previous page I had written my own birthday, like 26th November 1988. Let us find out it was what day. Okay. All right. So again till 1600, then 300, 1900, then I'll have 87 years, and then 88th year I'll start from January, then February of 1988, February till 26th November, till 26th November. So 1600 year will have 0 odd days, 300 year 1. Now 87 years I'll find out in rough. 87 years will have 4 2s and 4 1s. I'll have 66 days. 66 days will be my 66 years will be normal year, and this will be a leap year. So this will have 42. This will remain 66. Again I'll divide it by 7. This will become 7. This will become 3. 7 plus 3 is 10. Again I divide by 7, I get 3. So 87 years will have 3 odd days. You can see how did I get 20, 21. 4 2s are 8, 4 1s are 4, right? So I get 21. The difference of 87 and 21 is 66. So I can solve this to get this 3. So I better write this 3 here. Now from January, February, this is a leap year, so I should have 21, 29. February, March, April, May, June, July, August, September, October, January, February, March, April, May, June, July, August, September, October, and then November will be only 26 days, right? So I have 0 plus 1 plus 3. Now this particular part will come out to be 3 plus 1 plus 3 plus 2 plus 3 plus 2 plus 3 plus 3 plus 2 plus 3 and then plus 5. I'll remove the combinations of 7, 3, 3, 6 and 1, 7, 3, 3, 6 and then 1, 7, then 5 plus 2, 7. I get 3, 3, 6 plus 1. Oh, I've already erased this part. Okay. Let me do it once more. 3 plus 3, 6 plus 1, 7. 3 plus 3 plus 1, 7. Then 4 plus 3 is 7. I get 5, 3, 8 to 10 and then 13. 13 again I divide by 7, I get 6. 6, that is 6 is Saturday. So I was born on Saturday.